Hello everyone, welcome to Ijona Skills live webinar on Going Beyond VLOOKUP to Master Excel Formulas. My name is Nehal and I'm going to be your host today. Today's webinar will be presented by David Ringstrom. Before I hand it over to David and ask him to introduce himself and start the session, I would like to inform you that the session would be of 90 minutes and the attendees would be placed on mute to make sure that the presenter voice is clear to all our attendees and to avoid any unwanted noise. We will have a Q&A at certain intervals during the webinar. If you have any question during the session, you can share it through a chat window and David will answer those questions accordingly. We will begin now. David, I would request you to please introduce yourself and start the session.
Thank you. Hello, I'm David Ringstrom, a CPA in Atlanta, and welcome to Going Beyond VLOOKUP to Master Excel Formulas. Over the course of our time together today, I'm going to be sharing with you ways to look up information in Excel, and often the first worksheet function that folks learn in that regard is the VLOOKUP function. The V in VLOOKUP stands for vertical, meaning we're going to be able to look vertically up and down a column, and when we find a match on data, then we'll return the corresponding values there. So what the VLOOKUP function allows us to do is dynamically reference information in our spreadsheets. There are lots of other ways so that we can use to look up information, though that will include the HLOOKUP function. Sometimes folks use the match and index functions, and also we'll be looking at SUMIF and some alternatives there. Now I do have an update to Microsoft Office downloading at this moment that should only take another moment to install there. The reason that I'm installing this update is just last week Microsoft introduced a new type of lookup function that's called XLOOKUP. So the XLOOKUP function is going to let us do even more that we couldn't before in Excel, because XLOOKUP will give us even more flexibility for looking up information while we're working in Excel. So let me bring up an older version of PowerPoint so we can, while this update is installing here. So the presentation is designed to be interactive. I do encourage your questions as we go through the material today. Some of this learning comes from your questions, so do feel free to ask as many questions as you like. If I see the questions come in during the presentation, either by way of the chat panel or the Q&A panel, then I'll be happy to respond to those in a moment. Or also, we can also save our questions for the end there as well, if we'd like. Let's see. All right, so the update is installed. So let me get the PowerPoint up, and then away we will go. So if you have any questions after the webinar, you can email those. You may send those to support@ijonaskills.us. They'll relay the questions to me, and I'll be happy to get the answers to you. So don't feel like you're limited just to asking questions during the webinar. I extend an invitation for you to ask me questions about Excel after the webinar as well. I do like to lead off with a bit of background about the versions of Excel I'll be teaching from. I'll be using the Office 365 version of Excel. And Office 365 is the only version that will see that new XLOOKUP worksheet function. So Office 365 is the subscription-based version of Excel, which means that we have to pay for it on an ongoing basis. Historically, we only paid once for Excel by buying a perpetual license that we could use as far as we wanted into the future. But software companies are migrating toward that subscription model because there is that certainty of revenue there, where they have the ongoing revenue stream from subscriptions rather than hoping that users will upgrade to a newer version every few years. So if you want to see anything new in Excel, you will need to make sure that you're using the Office 365 version of Excel. But not all of us get a say in the version of Excel we're using. So the material I'm covering, for the most part, will relate as far back as Excel 2007. There may be a couple worksheet functions that will require Excel 2013 or later. And if we cross any of those, then I will let you know so that you're not looking for something that can't be done in the older versions of Excel. I will show you everything at least twice today. We'll be working a lot with formulas. So I'll I'll show you every formula on the PowerPoint slide, which will be broken down and then into all the components. Then I'll go over to Excel and put together a couple of examples using that worksheet function. You should have received the handouts for today's presentation already. If you did not receive them, you can email me directly by sending them to ask@davidringstrom.com. Always happy to make sure to get you the handouts so you have those for reference later on. Now I'm going to duck over to Excel for a moment, just take a quick peek and see if I do have the XLOOKUP function. And it looks like I didn't. The XLOOKUP function is not in my version of Excel yet. So with the XLOOKUP function, what they're doing is they are rolling it out selectively to folks that have signed up to be beta testers for Office 365. If that's something that you're interested in, you would go to the File menu in Excel and go down to the Account choice. And then if your version of Excel has a button for Office Insider, then you can sign up for the free Office Insider program, and that will put you in the queue to get earlier access to these new features that they're trying out. So I was hoping that that update would include the XLOOKUP function so I could talk about it today, but it's so new that it's not in my version of Excel yet. So we'll just focus on the things that are present in Excel, and I'll be including XLOOKUP in future presentations. So let's begin by looking at the VLOOKUP function. If you're not already using lookup functions such as a VLOOKUP, then you're doing a lot of work where you're referencing information in your spreadsheet directly, such as we see in cell B2, where we have to go figure out, okay, I want the value for account 4100. So we type an equal sign, we go over to column H where the account numbers fall, and we work our way down that column, find a match on 4100, and go across that row, and then we directly reference cell H2 in that case. VLOOKUP automates that, as lookup functions do, as long as we provide the correct parameters here. So in this case, there's 4 pieces of information that VLOOKUP needs to know. First thing it needs is the lookup value. So that is the value that we are looking for, in this case 4100, it's whatever's in cell A3. With the next argument is the table array. That is where we specify the cell coordinates for where we want to look. So in this case, I'm going to look at cell D1 through H5. And so VLOOKUP looks down the first column of the table array, in this case column D. When it finds a match, it travels across that row and returns information from the column position that we tell it to. So in this case, I want data from the 5th column. So that's how it's going to know to return March. Now you'll notice that my table array is limited to D1 through H5, where in reality the table extends further to the right. There's a reason why I stopped short at that column where I'm returning data from, which I'll demonstrate in a moment in Excel, so that we'll see that we will have when we're selecting the cells, we can have Excel give us the information to that 3rd argument there so that we know exactly which column number we want to return data from. The last argument indicates whether we want an exact match or an approximate match. And in this case, we want an exact match, so many of us are conditioned to type out the word false there. You can shorten that by putting a 0 at the end instead. So let's go over to Excel and see what that would look like here. So if you're not presently using lookup functions, then many of your formulas are going to look like this first formula I'm going to write, where we have to type an equal sign. We figure out, okay, we want 4100. We manually come over here. We manually track down the column. We find the match. We go across the row, click on that cell, and so that's what's known as a direct reference. Now, nothing wrong with direct references. Many of our formulas in Excel tend to be direct references. But when we have information that we're looking up from a list, particularly if we have to look up lots of things from a list, it's very inefficient and can be error-prone to go through and point to each piece of information individually there. That's where lookup functions can save us a lot of time and improve the integrity of our spreadsheets. So with VLOOKUP, what we'll do is we'll type equals VLOOKUP, and the first thing it wants to know is our lookup value. So here's my lookup value, so I'm looking for whatever is in this cell. Next up, I have my table array. So in this case, we're going to say D1 and I'm going to select through column H. The reason I'm not going all the way out to the right is I want to draw your attention to cell I6. Notice there's a little caption there that says 5R times 5C. That tells me that I've selected 5 rows. The number of rows doesn't matter, but also tells me I've selected 5 columns. And so if I select over to the column I want to return data from, that's an easy way to get the answer to the column index number. Because again, VLOOKUP is going to look down the first column of the table array. When it finds a match, it will travel across that row, and the column index number is how we tell it which column there within this area that we want to return information from. The final argument, we put in the word false to indicate that we want an exact match, and so it then looks up our information. Now, one of the challenges with direct references is we can have situations, let's say we changed our mind and we really wanted to count 40300. In this case, our direct reference is now broken. We have a data entry event where I change the account number, which then precipitates the need for me to go and rewrite the formula to reference the correct cell. Conversely, lookup functions flex with the spreadsheet. Notice it went further down to row 40300 and then went across and returned the corresponding value there. So that's where lookup values can change our relationship with our spreadsheets. Instead of us having to go and physically point to all the data, we can use lookup functions to reference the data directly there. So this is an example of an exact match. Let's also take a look at an approximate match. I'm going to close Excel for just one moment and launch it back again. All right, so with an approximate match, that's where we don't have an exact match, and we're going to find the closest match without going over. So we have the same 4 arguments. We have our lookup value, which in this case is going to be an income amount. We have our table array, which will be the cells that we want to look at, the column index number. What's different, though, is that we can also, instead of specifying the word false, we're going to put the word true. Now, there's actually 3 different ways to indicate that we want an approximate match. The one way is to type out the word true. A second way is to put the number 1 there in place of the word true. Or the third way is to omit the argument entirely. And I'm not a fan of omitting the argument because most of the time when we're using VLOOKUP, we're going to want an exact match. If we let ourselves get into a habit of sometimes specifying that last argument, sometimes not, then we run a risk of sometime when we need an exact match, we might indicate accidentally that an approximate match is acceptable, and that can cause Excel to return the wrong information. So it is best to be deliberate and specific about using VLOOKUP there to indicate categorically that you want either an exact match or an approximate match. So to see an example of an approximate match here, what we'll do we'll do a quick example. So let's say we start out with maybe 5,000 as our income level. So we want to figure out which tax bracket this taxpayer falls into. So what we'll do is we'll say equals VLOOKUP. The lookup value will be the income amount. Notice with the table arrays, when we're doing approximate matches, we want to start with the bottom of each tier. So we're starting out with 0. Now, many times it can feel like it makes more sense to list the top of each tier, but approximate matches are predicated based on the bottom of each tier. So that's why our table starts at 0 and then goes up from there. So we're going to select from column A over to column D where our percentages are, tell it we want data from the 4th column, and we'll type the word true there to indicate that we want an approximate match. And so in this case, this returns 10% because since this taxpayer earned less than $93.25, that means that they're in the 10% tax bracket. Now, let's say we change their income to $93.24, where they're still below $93.25. What if we change it to $93.24 and 99 cents, such that Excel would round it up to look like $93.25? In this case, because it's even a penny below 93.25, it still matches on that lower tier. Now, if at some point we come along and we add another penny there, that's the point where it then flips into the next tier there and returns that 15% bracket. So with approximate matches, it's like those TV game shows where the contestants are bidding on prizes. They have to have the closest bid without going over. And so same thing here, it's going to find the closest match without going over. So one way to do an approximate match is by putting the word true there. Another way is to instead come along here, get data from the third column, put a 1 there so I could put the number 1 instead of the word true. Or the third way, which is not recommended, is if we come along here and try this again here. Select those two ranges, data from the second column. Notice that the last argument, range lookup, has square brackets around it. Anytime you see square brackets around a portion of a worksheet function, that portion of the function is optional, which means you can omit it. And the risk with VLOOKUP is that if you omit that last part, then you get an approximate match, which could result in a data integrity issue. So one of the things the new XLOOKUP function is going to allow us to do is it's going to default to approximate matches. It's also going to eliminate the need to count columns, so we won't have to worry about counting columns, and also it will allow us to return more than one result, so we can return data from multiple columns instead of just a single column. So that's where Excel is headed with regard to lookup functions. But presently for VLOOKUP, in this case, I'm going to omit that fourth argument, and just so you can see, those are the 3 different ways that these are all valid approaches for indicating that I want an approximate match. Now, the V in VLOOKUP indicates that we're looking vertically up and down the worksheet. There's also the HLOOKUP function, which allows us to look horizontally across the row and then go down. So the arguments are pretty much the same. The first argument is the lookup value argument, telling you what we want to look for. In this case, we're going to look for a month name. Our table array in this case will go from D1 through Q5 because conceptually we could pick any month of the year. The third argument, rather than being a column index, will be a row index number. So that means that HLOOKUP is going to look across the first row. When it finds a match, it will then travel down that matching column and return a result from the corresponding row. And then we also have false or 0 for an exact match, or 1 or true for an approximate match. So to see that, we will contrast the two here. So I'll write the VLOOKUP again. We'll say equals VLOOKUP. So with VLOOKUP, my lookup value is going to be something that's going to be in the row. So that's why I'm looking for an account number. And then we'll come across and return data from D through H, getting data from the fifth column, and put the word false to indicate we want an exact match. So that's one way to match on the information. A different way would be the HLOOKUP function. So with HLOOKUP, we're going to say we're looking for this value, this month. Our table array, we will go ahead and look at the entire table going across there, and looking at data from the second row, and then we're going to put false for an exact match. So what's different about HLOOKUP is instead of looking down the column, it's looking across the first row and then coming down. Now, as we saw with VLOOKUP, if I changed it to, say, let's say 40400, it would travel further down and match on that value. Now, conversely with HLOOKUP, if I change this to January here, it now moves across and returns the value for January. If I put in the word account number, then it returns the account number. If I set account name, then it returns the account name. So notice it's traveling back and forth across the spreadsheet and then finding a match, going down that column, and returning a corresponding value. So 2 different ways to triangulate on the data there, where we can Either most of the time we're looking down the column because that's how our data is laid out, but we do have the option to look across the rows as well if we choose to. Now, if you poke around in Excel, you will run across a function that is just called lookup. And so there's no letter in front of it. And actually, the XLOOKUP function that I keep alluding to is basically what they did was they took some of the things that were good about the lookup function and then made them better. So the lookup function itself is obsolete. It's a worksheet function that is included in Excel for backwards compatibility. And I don't recommend that you use it in your spreadsheets because unlike VLOOKUP and HLOOKUP, where we can specify that whether we want an exact match or an approximate match, with the lookup function, you don't get a choice. It will first try to find an exact match. If it fails to do so, then it will return an approximate match. And typically with our data sets, I can't think of any situation where that either or would be acceptable. Either I know I'm looking for an approximate match or I want an exact match, but giving Excel permission to just arbitrarily pick either, that makes me a little bit queasy there. So I show you the lookup function, one, just so that you're aware of it, because you could run across it in the help files there and say, oh, well, that looks like a better choice. The big downside to lookup is that there's no provision for specifying an exact match or an approximate match. Now, the good thing about the lookup function is it's a bit streamlined. So we have a lookup value, which is what we're looking for. We then have a lookup vector. And so a lookup vector is going to be a single column or a single row of cells where we want to look for a particular value. And then we also have a result vector. That's where a single column or a single row that we want to return a match from. So this gets us out of having to count columns. That column counting we're going to see can be a big downside to VLOOKUP. If we alter the spreadsheet in any way, the column count has to go and be updated manually. So in this case, we don't have any column counting, but we also don't have the ability to specify whether we want an exact match or an approximate match. So the new forthcoming XLOOKUP function is going to be structured much like the lookup function is, so we won't be counting columns, but there'll be some additional arguments that we can specify that where we can do exact matches or approximate matches and provide a lot more parameters there. So let's take a look at the lookup function itself. So we saw with VLOOKUP that we told it what we're looking for, where to look, we specify a column number, and then we put a 0 for an exact match. Let's contrast that by using the lookup function. So when we go and use the lookup function there, we provide a lookup value. We then provide a lookup vector. So I'm going to look here at D1 through D5. And when there is a match, I want to return the corresponding value from H1 through H5. So when I put my formula in, initially it looks like two different ways to get it exactly the same result. And in fact, if I looked for 40300 in both of those, they would both return the same result. But let's say that I look for count 40500, which does not exist on my list here. Notice that VLOOKUP returns #NA. The #NA signals that it could not find a match, NA meaning not available. Conversely, the lookup function says, well, I couldn't find an exact match, so I'll just default to this approximate match and return that for you instead. And so that's where that can be a problem, because since the formula returns a result, we can be led to believe that it returned the result that we were expecting as opposed to some arbitrary result. So that is the trade-off with the lookup function in the coming months when XLOOKUP has made its way to everyone using Office 365. We'll have the flexibility of the lookup function, but it'll be modernized and streamlined and a lot more powerful. So one situation that causes VLOOKUP to return #NA is not finding a match on what we're looking for. Another situation is when the cells that we're looking for are empty. So notice here that in this case, we are looking for, so if we didn't find a match of 40500, it returns #NA. But also, if the cell that has the lookup value is empty, that too will cause a pound in a error. And so there can be a trade-off with VLOOKUP where we have a chicken and egg situation where we're looking for a particular value, but we can't return the match on it because there's nothing for it to match on. So that too will cause VLOOKUP to temporarily return pound and egg. Now there are ways to manage that situation so we can return something else instead, as I will show you. But let's just first see what that looks like. And we'll just use this one here. So let's say that in both situations I'm looking for count. In the first situation I'm looking for count 4 or 500. If I type out VLOOKUP, there is my lookup value. For my table array, we'll say D1 through H5. I'll then press the F4 key. So what the F4 key does is it puts the dollar signs around the formula so that it locks in that cell reference, so that if I copy the formula down as I'm about to, then it always refers to D1 through H5 as opposed to shifting to becoming D2 through H6 and D3 through H7 and so on. So the easiest way to get those dollar signs in your formula is to press the F4 key as soon as you select that range. We want data from the 5th column, and we'll put a 0 this time. 0 is our shortcut for indicating we want an exact match. So notice that in this situation, VLOOKUP returns pound in A. And also, if I drag that formula down, it will also return pound in A here as well. So in this case, this formula is looking at A3, and particularly if I erase that cell. So cell A3 is empty, so that too causes VLOOKUP to return pound in A. Now, if I fill in these cells with something valid, such as 40100 and 40200, then both formulas return the proper result. But if I look for 40500, that's going to give me a pound in A. If I erase that value, that too will result in a pound in A. So we see that for using lookup functions, if we're relying on the user to enter the values, to make sure that the user puts the values in correctly, because if they transpose something, for instance, they put 4100, 41,000 like that, that's a transposition. That means it's not going to match there. We have to put in the number correctly. So there is a way in Excel to help the users out so that they can be more inclined to make a valid choice. That is by way of the data validation feature in Excel. So what data validation lets us do, among many other things, is create an in-cell drop-down list so that we can limit the user to making valid choices from a list. So to begin, we would select the cell or cells that we wish to apply data validation to. Step 2 there, we're going to choose a data validation from the data menu. That will then bring us to step 3, where we'll be inside the data validation dialog box. And so step 3 there, we're going to choose a list. We're going to find that inside data validation, that it's going to, inside the data validation dialog box, it defaults to allow any value. That means that you can type anything you want, anywhere you want within an Excel worksheet. Leads to a Wild West atmosphere. So in this case, we're going to put some fences around certain worksheet cells where you can only enter values that are on a prescribed list. Step 4 is where we specify that list, and in this case, in the context of VLOOKUP, we would be choosing from that first column. So we're going to be choosing from D2 through D5. Not choosing D1, I don't want the user to be able to choose the word account number, but I'm just going to choose just the account numbers themselves. So step 5 there, we're going to go to the Input Message tab. Step 6, we're going to put in a description there, because another thing data validation lets me do is create some in-cell documentation to document what's going on with that restriction there. So this documentation will appear when the user first clicks in on the worksheet cell. So I'll describe that as account number, and that's step 6. Step 7, I'll say choose an account number from the list. Now, there can be situations where the user either purposefully or inadvertently violates the rule, and so that's what step 8, the error alert tab, allows us to do. That will allow us to specify some feedback in case the user doesn't follow the rules. So we can put in invalid input as a title, and then I'll just reiterate the main instruction. I'll say you must choose an account from the list, and then I'll click OK. So the user will only see the error alert if they trigger it by typing a value that's not on the list. When the user clicks in on the worksheet cell, a drop-down arrow will appear as well as the on-screen instructions, and if they make a choice from the list, then the input will be accepted. If they try to bypass that list and type in some other value, then Excel will stop them in their tracks. So this is a way that we can ensure that our users fill in something valid so that VLOOKUP can then always return a proper result. So what we'll do here is, let's say we'll use data validation on, actually I need the VLOOKUP formulas there, so I'm going to put these back. So we have our VLOOKUP. What we're actually going to focus on here are these two input cells. So I'm going to erase them for the moment and go to the Data menu, click on Data Validation. So that's in the Data Tools section, which brings up the Data Validation dialog box. On the Settings tab, notice it says Allow Any Value. That means that normally you can go to any worksheet cell, type anything you want. But in this case, we're going to pull down this list and choose from the restrictions, and one of the restrictions is to allow from a list. So I'll choose list here. The source of my list will be the cells that VLOOKUP would match on, so D2 through D5. To enhance this feature, I'm going to go to the Input Message tab, and we'll call this Account Number. We'll say choose an account number from the list, and then that's what the user will see when they first click on the cell. If they try to circumvent the rule, then we'll give them some stronger feedback, and so often I'll put invalid input, and I'll say you must choose an account from the list, just to reiterate the instruction. So when I click OK, notice then that on cell A2, I can't tell anything special about it until I go click on it. When I do, the instructions pop up. Here's my drop-down list. I can choose for 100, and that's accepted, and VLOOKUP returns a result. Now, I can come here, and I can type in 40300, and that will work. But if I tried to type in 40500, and then I press Enter, that's when I'll get the negative feedback. I must choose something from the list because of the data validation restriction there. So I can click Cancel. I can pull down the list and type 40300, or I can type in a value. I'm not limited. I don't have to use the drop-down list, but I do have to, if I choose to type in the value, I have to type in a value that is on that particular list there. Otherwise, it will be rejected. So we've seen some situations where VLOOKUP can return a pound in A error. And so one way that we can prevent those errors from popping up in our spreadsheet is to use the if error function. The reason that the pound in A can cause a problem is that it has a cascade effect. If, let's say, we have a series of numbers that we're trying to add up, and one of those cells that we're trying to add up returns pound in A, then the sum function that we're adding up those cells will also return pound in A. So we generally cannot leave VLOOKUP on to its own devices there, where it can just return either a number or return an error. Often what we'll do is we'll wrap the if error function around the outside. Now, if you're not familiar with the if error function, which was introduced back in Excel 2007, you might still be following on some old habits where back in the day, prior to Excel 2007, we had to take a more elaborate approach where we'd use the if function, and inside the if function we'd put an is in A function. So what is in A does is it returns either true or false, meaning whatever's inside it either returned a pound in A error or did not. And so if it does return pound in A, then our if function could display a 0. Otherwise, we could repeat our VLOOKUP, and it would then would do the actual calculation. So I'm not a fan of using the if and the is in A because, one, notice that it almost doubles the size of our formula. But also, from an editing standpoint, if I have to go back and edit that formula, I have to make my changes in 2 different places. And anytime I have to do something more than once in Excel, very easy for things to blur or just for someone to be unfamiliar with the requirements and miss changing it in the second place, and then you have an issue in your spreadsheet there. So the if error collapses that down. We put if error around the outside of VLOOKUP. If VLOOKUP returns a proper result, if error will show us that result. If it triggers a pound in A error or any other type of error, it will display an alternate value, such as a 0. Or we could put 2 double quotes in place of that 0 to make the cell appear as if it were empty. Or we could put a message inside the double quotes, such as the word missing, and then that would be some feedback to the user there. So we'll see here. That if we leave VLOOKUP on its own there, that's what our formula will look like. And in this case, for 40500, it returns pound in A. So I'm going to take this VLOOKUP, I'm going to copy it all the way down. And so on this second row here, I'm going to use the if error function. So if error has 2 arguments, has a value argument. And so that value argument is some sort of calculation that could return a pound sign error of any sort, such as pound value, pound ref, pound in A. If error will cover up any of those. And if any of those errors surface, then it will display the value if error, which in this case I'll put a 0 there. So we'll see then, that's what our formula would look like with the if error function. If you were not using the if error function, then the formula might look like this other approach, where what we used to have to do was use an if function, and then we'd have a logical test. So the logical test within an if function is some sort of calculation that will return either true or false. So one way to get a true or false is to use one of the is functions, such as is in A. So if I put VLOOKUP inside an is in A, it will either return true if it returns pound in A, or false if it does not. So is in A with VLOOKUP inside comprises the logical test. My value of true, in this case, if it does return an error, I want to display a 0. Otherwise, I want to repeat the VLOOKUP. So I have to go in there, copy the VLOOKUP out, put it at the end there, and so that's what that formula would look like. So in all of these situations here, if VLOOKUP has something valid to return, then it returns the result. And so if I'm summing these values, notice that my sum is going to return the proper result. But if I were to come back and change these to 40500, because this one returned pound in A, that in turn causes my sum to return pound in A. So very often, if we're going to use VLOOKUP, we also need to use a second function, which is the if error function around the outside, so that it handles the pound in A error and more gracefully. Now, one downside to the if error function is that it's overly broad, because one type of error that can arise with VLOOKUP is a pound ref error. The pound ref error surfaces when we change the structure of our spreadsheet, such as by deleting a column, and so suddenly that makes our column count be off. Or also when we're first writing the formula, if we just eyeball the column index number, then we can end up referencing the wrong position there. So the pound ref error, whenever you see pound ref, that means that if you see it when you first wrote the formula, that you've chosen a column index number that is greater than the number of columns inside the table array. If I selected a 5-column table array, but I tell Excel to get data from the 6th column, it physically cannot. So that's one way that a pound ref error will surface. But another way is that we set up the spreadsheet and then we change our mind about how the spreadsheet's going to work, and so we start deleting columns. A downside to VLOOKUP is that the column index number is static. It doesn't change. If you delete a column, that 5 is not going to change to a 4. It remains fixed at 5, but the table array adjust becomes D1 through G5. That too will return a pound in A error. So to see what that would look like here, what we'll do let's do 40100. And so we'll say VLOOKUP, looking for that, D1 through H5, fifth column, and a 0. So that formula at the moment properly returns a result. But let's say I was in a hurry. I said VLOOKUP, and it shows my table array. I didn't pay attention to that little caption, and I say, oh, that looks like 6 columns. So I put 6 there and 0 for an exact match. That's going to return pound ref, because in this case, I've specified a 5-column range, but it's telling me that I want data from the 6th column of that 5-column range. So another way that a pound ref error can arise, let's say that I came along and I deleted column E. That too can result in a pound ref error, because what's happened here, my range has shortened such that it is now D1 through G5, and I'm returning data from the 5th column of a 4-column range. So that's what a pound ref error indicates in conjunction with VLOOKUP. Means that you have to go back in and adjust the column index number. So if I change the column index number to 4, that clears that up. Same thing here. Then VLOOKUP can do what it does. Now, if we had if error wrapped around the outside of these, then we might think that there just wasn't a match when actually it was a different problem. So that's where, if you're using Excel 2013 or later, there is a better worksheet function to use in this context that is IFNA. So IFNA is more specific. It only covers up pound NA errors. It shows any other kind of errors that surface inside VLOOKUP. So it has the same 2 arguments. There's a value argument, and then there's a value IFNA. And so if you are using Excel 2013 or later and not sharing spreadsheets backwards with anyone using Excel 2010 or earlier, then IFNA is the better function to utilize there. So to see what it looks like, we'll contrast the 2. What we'll do here, we'll create our VLOOKUP. So we have our value. We just select D1 through H5, press the F4 key, getting data from the 5th column, 0 for an exact match. So initially, we'll have the same formula on both rows. Now, on the first row here, I'm going to wrap the if error function around the outside. So because the function returns a proper result, I can't tell there's anything different here. The second function, we're going to wrap the IFNA function around the outside. So let's now see how these 2 differ. If, in this case, I change this to 40500, both of them return a 0, because neither one of them found the match on account 40500, and so it means VLOOKUP returned pound in A, and so because of that, if error returns a 0, if in A also returns a 0. Now, let's say that I came along and I deleted column E. At the moment, because I'm looking for an account that doesn't exist, they're both returning a 0. But let's see what happens if I change the account number back to something that is valid. So I'm going to change it back to 40100. In this case, the if error function, because it covers up pound ref, then that hides the pound ref error from me. I'm going to have to look harder to realize that my VLOOKUP is broken. Conversely, the IFNA function only covers up pound and A errors. So it returned a 0 for 40500. For 40100, it could find a match, but it couldn't get there because the column index number was incorrect. So if I update the formulas here to show you how the formulas changed, both of these formulas at the moment are looking at D1 through G5, which is a 4-column range there, and both are trying to return data from the 5th column, which they cannot do. So if error just says, well, that's an error, so I'm going to present the alternate value, whereas IFNA says, well, it's not a pound in A error, so I'm going to show you whatever the error is. So that's the distinction. IFNA is more specific and gives you better feedback than the if error function. So if you're using Excel 2013 and don't need to worry about backwards compatibility, IFNA is the better function. If error certainly works, but just realize that it does cast a really broad net. Now, we can also have situations where we have a VLOOKUP that it looks like it's written perfectly correct, but still it returns a pound in A error. And I remember this, actually, just to date myself, when I was learning lookup functions, it was back in Lotus 1-2-3. And I one day remembered struggling because I had just mastered VLOOKUP, and then I hit a data set where there was a nuance in the data. And I was wanting to pull my hair out because I had just mastered this function, but it wasn't returning a match. And it required some study before I finally realized that it wasn't a problem with the formula, but actually with the data itself. So I'm going to first show you some of the tests that I'll do when my VLOOKUP doesn't find a match, and then I'll show you an easy way to clean up the situation that has arisen here. So what we'll do, find my example. There we go. So in this case, I have a VLOOKUP that is written correctly. I'm looking for whatever's in cell A2. I'm looking at D1 through H5, data from the 5th column, and 0 for an exact match, and yet the formula returns pound in A. So that can be really frustrating when that happens. So one of the first things that we're going to look for is there an extra space at the end of either one of these numbers here? Because that's the first culprit. To check that, we're going to use the length function. So it's abbreviated LEN. What the length function does is it tells you how many characters are in a given cell. So there's 5 characters in cell A2. So we'll also check then, do the length function on cell D2. We'll check that. And so there's 5 characters in both. In that case, we've eliminated the risk of there being a space on the end. So we know it's not a space. So we know it's then something else. So the other thing that can be a bit tricky to figure out is when numbers are stored as text. And so a way to do that is to use the isNumber function. So in this case, if we reference cell A2, it returns the word true because cell A2 is a number. Now, let's say we go and use the isNumber function again, and we use it on cell D2. This time, isNumber returns false, meaning that even though it looks like a number, it's actually embedded in that cell. Excel is treating it as a word. In fact, if we wanted to prove that out there, if we said isText, we could reference cell A2. It would return false in that case. And then isText, referencing cell D2, would return true because, indeed, that number there is stored in there as text. So how do we resolve situations where numbers are stored as text? This, fortunately, is one of the easiest things to clean up in Excel. To begin, we're going to select the cells that have numbers stored as text. Step 2, we'll go to the Data menu. Step 3, we'll go to Text to Columns. That will bring up the Text to Columns wizard, and in this case, all we need to do is simply click Finish, and that will transform the numbers to all be any number stored as text, convert them to numbers, and then all of our formulas will work. So to see that here, I'm going to select cells D1 through D5, going to go to the Data menu. We'll click on Text to Columns. That brings up the Text to Columns wizard. Ostensibly, the Text to Columns wizard is used to break text up into multiple columns. But we're not going to do that in this case. We're just going to do a bit of cleanup here. So notice all I'm going to do is just click Finish. I'm not going to go through the wizard. I'll simply click Finish. Suddenly, VLOOKUP returns a result. My 2 is numbers both return true, and my 2 is text both return false. That means that I have the numbers on the same footing there. So for your data to match, you either have to eliminate the spaces on the end, or you have to compare numbers and numbers, or text and text. We can't have numbers in one cell and then text in the other cell. Now, cleaning up spaces in the data can be tedious, so there is a workaround for that, where we can use what's known as the wildcard character. So in this case, rather than just a single space, I actually have some extra words in there, but this would work the same way if there were spaces as well. So for my VLOOKUP, what I can do is tell it to find what I'm looking for, do an ampersand, and put an asterisk inside double quotes. And so then I have D1 through G5, which is where I'm looking, returning data from the 4th column, and 0 for an exact match. The asterisk tells it, the asterisk serves as a wildcard, so that changes it to find a match on anything that begins with 40100. And so that can be used when there's other data in the same cell. Can also be used to overcome situations where you have trailing spaces. Sometimes somebody bumped the space bar. Bumping the space bar, like in an accounting program, really hard to notice that you bumped the space bar unless you go and look for that. Often doesn't surface as a problem until we get the data into Excel and we're trying to match together. That's when we can run into some frustration there. So to see what VLOOKUP will look like with a wildcard character, what we'll do is if we had just a straight up VLOOKUP, so we just said VLOOKUP, looking for this value, looking at D1 through G5, 4th column, and then a 0, that returns pound and A because it cannot find 40100 in isolation there. So if there's other data in the cell, the way we make VLOOKUP be more flexible is we add in the wildcard character. So add in that asterisk, then D1 through G5, 4th column, 0. Now it can return a match there. We can put the wildcard at the beginning as well there. So if I want to find something that ends in services, I can say VLOOKUP, put the asterisk at the beginning, and then tack on the word services. Look at D through G, 4th column, 0, and then that lets me return a match there as well. So anytime you need to do a partial match, you can insert the asterisk in there, and that changes it to either a begins with or an ends with, or we could even put asterisks on both sides to find something that was in the middle there. Now, once folks really feel confident about VLOOKUP, they start venturing into other worksheet functions in Excel, and that can include the match function. And at first, you might look at the match function and think, well, why in the world would I need to know that? Because the match function doesn't actually return data, it returns a position number. But I will show you in a moment how the match function can make your VLOOKUP be more flexible. So the match function has 3 arguments. There's a lookup value, there's a lookup array, and then there is a match type. And so the lookup array is going to be a single row or single column. The match type, we have less than, we have an exact match, or we have greater than. So I can say, use the match function to look across row 1 for the word March and return an exact match. In this case, it returns a 5, meaning it found the word March in the 5th column. Well, I can take the match function and embed it inside VLOOKUP and have a double lookup, because I can have VLOOKUP look down the first column, I can have match look across the first row, and then triangulate in on the data. So what that would look like is this. So instead of having a static column number for the column index number, instead what I can do is use the match function to figure out the column position and then wrap my VLOOKUP around the outside, and then I have a double lookup. I can then triangulate in on the data there. So we see there's our traditional VLOOKUP. We'll leave that formula in place there. To write the match function, we'll say equals match, tell it what we're looking for. So I want to match on whatever's on B1, so I'm going to put the F4 key to put dollar signs around it. And then I'm going to say D1 through Q1, and so again I'll press the F4 key, and then a 0. So that returns a 5 because it found a match on the 5th column. Now let's say I put in January here. Now the match function returns 3 because it found a match on the 3rd column. If I put my name there, such as David, it returns pound and A because there's not the word David does not appear in cells D1 through Q1. So just like VLOOKUP, it's going to return pound and A if it cannot find a match. But now that I have the match portion written, I can copy it down to the next row. I can wrap the VLOOKUP function around the outside. So for VLOOKUP, we'll look whatever's in cell A4. Our table array this time would be the entire table, D through Q. Instead of a single digit or instead of a number for the column index number, we have a formula there. So we're calculating the position number, and then we put a 0 for an exact match. So remember earlier when I went and deleted columns from the spreadsheet, I broke my VLOOKUP. So let's see what happens here. I'm going to come along, I'm going to right-click on column E and choose delete. And what happens there, this traditional VLOOKUP now returns pound ref because the cell reference changed from D1 through G5. It's trying to return data from the 5th column of a 4-column range. Now the match function is now returning 4 because it shrank itself up. It's looking for the word March in D through P. And then in turn, my VLOOKUP down here that has the match function inside flexed with the change there because it's looking at D through P instead versus D through Q, and the match function is looking at, on row 1, D through P, again, instead of D through Q. So putting the match function inside VLOOKUP eliminates the need to count the columns. Also eliminates that exposure that we have by having that static number inside the VLOOKUP function there. That static number can cause lots of problems and lots of frustration because it doesn't flex with any changes to the spreadsheet there. You have to go through and physically change it instead. Now, another way that we can improve the integrity of VLOOKUP is that in addition to having issues with how we insert or delete columns, when we add more rows to our VLOOKUP, VLOOKUP doesn't see the additional rows. That can be another data entry change that means we have to go back in and rewrite the formula. So a way to automate our VLOOKUP so that if we add more accounts at the bottom, that it will see it automatically is to make our source list into a table. So to begin, we're going to select any cell within our list. Step 2, we'll go to the Insert menu. Step 3, we'll choose the Table command. That will bring up the Create Table dialog box, from which Step 4, we'll click OK. Now, optionally, what we can do is we can then assign a name to our table by way of the Design menu. And so on the Design menu, the first space, there's a spot where we can assign a name to the table. So we can call it Budget. And if we do so, we can then refer to our lookup area by the table name rather than the cell coordinates. But the main takeaway that the table feature adds to us is that whether we reference it by the table name or the cell address, either way, the formula will automatically expand to see any additional rows that we add to our data. So to see that, what we'll do here, we're going to write our VLOOKUP two different ways. We're going to have our VLOOKUP, and we'll say D1 through H5, fifth column, and a 0. So let's say that I'm looking for count 40500. Right now it returns pound and egg, because 40500 is down at the bottom there. So what I'm going to do is I'm going to leave that formula there, and instead I'm going to go turn this into a table first. I'm going to go to the Insert menu. In fact, let's change this back to 40100. I'm going to make this into a table, so I'll go to the Insert menu. The very first section is the Tables section, and that's where I will find the Table command. So I'll click on that. That brings up the Create Table dialog box. It says, confirms my table has headers. I can click OK. So notice it's shaded every other row. I'll show you how to deal with that shading. And the other thing that we can do is we can come along, and when our cursor's inside the table, we have a Design menu. So we can go to that Design menu. We can put in the word budget here and press Enter. And so now there is our budget range. So the other way that I could refer to that data is I could say VLOOKUP and type in the word budget and fifth column and a 0. So two different ways to get the same result. But remember, I said I was going to add another account. So let's say that I come along and I grab this data here and I paste it there. I change these to look at 40500, and they both return a result. That's because this formula here rewrote itself. It's now looking at D1 through H6. And this formula is the same here with the budget name. But notice that normally VLOOKUP, you would have to manually go and increase the row numbers to see the additional data. And in this case, VLOOKUP takes care of it for us. So it finds the value, it returns the result for us. So D1 through H6. So if you want your formulas to rewrite themselves automatically, if you just simply take the data the formulas are looking at, turn it into a table, that makes the formulas be self-updating. So this works for VLOOKUP, and this works for any worksheet function in Excel. So any worksheet function that we want to work with in Excel, if we make the data into a table, then it's on autopilot where the formulas will rewrite themselves rather than us having to go back in and manually rewrite the spreadsheet on our own. If you do make the part of the spreadsheet into a table and then change your mind, there's a couple levels of changing your mind. One, you just simply might not want the shading in the spreadsheet. So to eliminate the shading, you can go to the Design menu, which appears when you click on the table. Over to the right, there's a Styles section. If we pull that Styles section down, step 3 there, we can choose None, and then we eliminate the shading there. So that keeps it as a table, but it gets rid of the formatting. But if you no longer want it to be a table at all, you can then click Convert to Range on the Design menu. It'll ask you, do you want to convert the table to a normal range? You can say yes. That makes it into a regular range of cells, but then it also puts the onus back on you to have to rewrite your formulas if you expand the data there. So typically, if we use the table feature, we'd want to keep it there, but early on, if you're experimenting with it and then you decide to walk it back, that is how you can walk back the table feature if needed. So if I want to just simply get rid of the shading, I can click on the table, go to the Design menu. When I pull down the Styles section here, first choice is None. In fact, let me turn on my captions here. So we'll see that when we hover over it, the word None appears. So that means that we're just getting rid of the shading there. It's still a table, and we have all the automation. We just don't have the formatting. But if we were to click Convert to Range, it says, do I want to convert the table to a normal range? I'll say yes. That made it into a normal range, but now I'm not going to have the table name there anymore. It's now been replaced with the sheet name and the cell address there. And so it's now a static formula that will no longer rewrite itself. it's incumbent on me to if I add another row, I have to go in and rewrite the formulas on my own there. Now, there's a progression in Excel that folks walk down, and with Excel, once folks have mastered the VLOOKUP function and then gotten frustrated with some of its constraints, because one of the constraints with VLOOKUP is you can only look to the right. So that's something that the XLOOKUP function is going to address. You'll be able to look up data to the left or the right with the XLOOKUP function that's coming out in the coming months. But another way that you can already look to the right or left is by combining the match function and the index function together. So what match and index allow us to do is to triangulate on the data in ways that VLOOKUP won't let us. So we've seen the match function where it returns a position. So in this case, we're going to use the match function to return a row number. And then the index function will actually return the data that we're looking for. So to see an example of that, what we'll do, we'll leave our VLOOKUP in place. We've seen a number of examples of VLOOKUP, but I'll go and rewrite the match function. So I'm going to say equals match. And so I'm looking for this value. I'm looking for it in D1 through D5, and then 0 for an exact match. So that's going to return a number. So it returns the number 2. Now, I don't really care that 40100 is on row 2. What I want is a corresponding piece of data that relates to that. So we'll pull down the match function, and we'll wrap the index function around the outside. So for the index function, I can say H1 through H5. And so Excel is going to go to column H and return data from whatever row number that the match function tells it to. So the match function is providing the row number here. And so, notice that we're not counting any columns there. Another thing you'll notice, I can come along here, I could right-click and I could delete column E. That breaks my VLOOKUP. Remember, VLOOKUP is fragile in that regard. Match and index says, well, no problem. Now what I'm doing is I'm returning a value from column G based on finding a match in column D. But remember I mentioned that match and index can look up data to the left or the right. What if I took my account numbers and moved them to the right? So I moved them to the right of March. That still doesn't cause a problem for me because now the index function says, okay, I'm looking up a value from column F based on returning a match from column G. So the match and index functions segregate the lookup capability there. Match is independently identifying the row number, which then frees index to look up data from anywhere that we want in the spreadsheet. So that's another thing that the upcoming X index is going to do. It's going to eliminate really the need to pair together match and index because X index is going to, or X lookup is going to allow us to do these types of lookups and even much more. So we can use match and index with a single lookup. If we're really motivated, we can pair together two matches. I don't tend to do this very often because usually VLOOKUP with a match inside will accomplish what I need. But I could tell the index function to look at columns D through Q, and so I would have two matches. The first match would identify a row number. The second match would identify a column position. So you can use two matches inside the index function if you choose. Typically, a single match is sufficient for a lot of lookups, or also using VLOOKUP and then pairing the match function inside will accomplish what you want. But if you just really needed complete flexibility, then putting two matches inside the index function would allow you to accomplish that. Now we're going to move on and take a look at the choose function for a couple reasons. One, the choose function gives us the ability to do lookups inside a worksheet cell. And the choose function can be a helpful alternative to writing the if function. So let's say if we looked at cell B2, we might have a formula: if A2 equals 1, display the word apples. If A2 equals 2, put the word oranges. Otherwise, put the word bananas. And so Excel allows us to nest up to 64 levels of if functions in that fashion. And that nesting builds what I like to term a house of cards inside Excel, because the bigger the formula gets, the more ifs you have, the more commas and parentheses you have, the harder it is to test all the different permutations there. Conversely, the choose function lets us do a lookup based on an index number. So that index number is going to be a number between 1 and 255. And what we're able to do is to just then provide our list, and we can look up actually 254. So we can look up to 254 items there. And so we just separate each item with commas there. So to see what the choose function looks like, we'll contrast these two here. So if I were writing this with an if function, I'd say if A2 equals 1, display the word apples. If A2 equals 2, display the word oranges. If otherwise, put the word bananas. So that's just an example of using an if function to get at a solution like that. And formulas like that work until they don't. Notice if I drag this down here, I get to the fourth choice. Well, there's not a fourth choice. I didn't provide for a fourth choice. So it just defaults to whatever the third choice was, because that's the nature of the if functions. Conversely, for the choose function here, if I said equals choose, then my index number would be provided by a cell reference here, so whatever cell that is, and then say apples, comma, oranges, comma, bananas. Close the parentheses, copy that down, and so there is our pound value error. Returns pound value because we referenced a fourth value, but we only gave it 3 to look at. So we get some feedback that we don't get necessarily with the if error, with the if function. So choose can be used as an alternative for a lookup if you don't need to necessarily list everything out in the spreadsheet. Because the other way that we could get at this information here, if we were using VLOOKUP, notice I could have 1, 2, 3. Get rid of that shading there. A third approach here would be VLOOKUP. So I could say VLOOKUP, looking for that number, looking at these cells, second column, 0. And so that would be another way to triangulate in on those values. What I like about the choose function is that I don't have to take up any space in the spreadsheet. My list is listed inside the worksheet function. So in place of having the words there, apples, oranges, bananas, I could also put formulas in there or numbers. So this is useful not just for displaying words, but for also managing calculations as well. Now, if you particularly wanted to look up data from the left, you can use VLOOKUP to do that if you use the choose function. And this will just show you what's possible when we really start pushing the boundaries of Excel. We can use the choose function inside VLOOKUP to virtualize our data ranges and flip them around. So if I were trying to look up the account number from column E, with VLOOKUP, I can't return a value from column D because the data is in the wrong order. I have to typically pick it up and flip it around. Conversely, though, I can use the choose function to virtualize the data and flip it in a different order there. So I'll show you briefly what that looks like. So let's say here that I have my account numbers and then my account names. So normally I would not be able to use VLOOKUP to look this up because the account numbers are in the wrong order. So what we're going to do here is we're going to say equals VLOOKUP. This is my lookup value. My table array, I'm going to provide the choose function. I'm going to put a curly bracket 1, 2. Because what I'm doing is I'm telling Excel that I'm going to have 2 columns. So basically I'm setting up 2 different bins to look up information from. I can then specify D through B1 through B4 as the first bin, and then A1 through A4 as the second bin. We then close our choose function, tell it we're looking up data from the second column, and then a 0 for an exact match. And notice it enabled me to look up the account number, even though I'm looking at from the left there. So if I put in 300, it would return AP. If I put in 200, AR, 100 would return that. So that is a way with VLOOKUP that you can get VLOOKUP to look up data from the left. This works in any version of Excel there. And so the 1, 2 there, that's creating an array. So we're setting up, it's a way of virtually picking up those 2 sets of data, picking them up off the spreadsheet, and virtually flipping them around in midair so that we can then do a VLOOKUP based upon those values there. Now, if you are looking up words, then you might have to resort to something like that or use match and index. But if you need more flexibility with adding up numbers, the SUMIF function gives us much better flexibility there. So SUMIF1 has fewer arguments. There's only 3 arguments. Also, SUMIF returns a 0 if it doesn't find a match, as opposed to #NA, which means we don't have to wrap the IFERROR function or IFNA function around the outside. Also, SUMIF is able to add up multiple values. A constraint of a VLOOKUP is once it finds the first match, it stops looking. And so you can only return a single match with VLOOKUP, as opposed to SUMIF, it can add up multiple values here. So to get a sense of that, wrong file. Let me open up the right file. So let's say that we're trying to look at the values for count 40200. We use VLOOKUP and we tell it to look for that, 5th column and a 0. It only returns 1 result. It returns the first value. So a constraint of VLOOKUP is that once it finds a match, it quits looking. Now conversely, if I say SUMIF, there's 3 arguments. There's a range argument. So I can say D1 through D5. I can tell it what I'm looking for. I can also tell it what I'm adding up. Close the parentheses there, adds up both values. So remember what we ran into earlier. If VLOOKUP cannot find a match, such as account 40500, it returns #NA. Conversely, the SUMIFS function returns a 0 there, so we don't have to worry about handling the error. Either it adds up the numbers or it returns a 0 for us. So anytime you're adding up numbers, SUMIF is typically the better function to use rather than VLOOKUP because it's a little bit shorter. You also don't have to worry about the error handling. But also I can take my count numbers and drag them to the left over there. Remember, that's going to break my VLOOKUP. It's going to return #NA because it's all confused now. And it's also because it can't find 40200 in column D, so it's all messed up here. Conversely, this formula is looking at column H, adding up values in column G. As soon as I fix the account number, then we see it adds up those values there. So SUMIF gives me the flexibility to look to the left or the right. Now, SUMIF only allows me to look up based upon a single criteria. There is another function called SUMIFS, that lets me look up based upon multiple criteria. So what the SUMIFS function allows me to do is to add up based upon multiple values here. So with SUMIFS, I can provide up to 127 criteria. So with the SUMIF function, I can only provide one criteria. Because SUMIFS allows so many criteria, we first tell it what to sum. So my first argument is what do I want to sum? I want to add the values up from column J. Then my first criteria range, I'm going to say look at column E for department B. My second criteria range, I'll say look at column F for account 40200. And when it finds a match on that, it will add up that one value. So to see what that looks like here, if I were using SUMIF, I could say SUMIF, and I could say look at F1 through F5 for account 40200, and then add up those corresponding values. So we saw that formula earlier that adds up both of those results. Now, for SUMIFS, I can use it with one criteria or as many as I choose. So if I wanted to use SUMIFS, I would first specify I want to add up values in column J. That's my sum range. Then my first criteria range would be F1 through F5, and then I'm looking for that account number. And so that is simply two different ways to triangulate in on the same result. So at that level, SUMIF and SUMIFS are interchangeable. It's just a matter of what order do we put the arguments in. But for SUMIFS, what we can also do is we can say I want to add up these values based on finding a match of E1 through E5 on there, and then F1 through F5 based on that account number. So matching on both the department and the account number. And so SUMIFS allows me to be more specific and add up the values matching based up on, matching on up to 127 criteria. Another thing I can do with SUMIFS is I can introduce operators, and I can do that with SUMIF as well. So what an operator allows me to do is to be more specific. So in this case, I could say add up anything that is greater than or equal to, in this case, 40200. So operators allow you to take your lookup functions even further there. So if we look at our SUMIFS, two different ways to get at this result here. I could say SUMIF, and I could say look here, and the operator here is going to be greater than or equal to, and so I'm basically saying take a greater than or equal to and combine it with whatever's in cell A2. So the technical term for that is known as concatenation. You can use the ampersand in place of the concatenate worksheet function to combine text together. So I'm combining those values together and then tell it what to add up, which is H1 through H5, and so it adds up those results. If I change this to 40300, then it will only add up those values. So I can do that with SUMIF or SUMIFS, and so I would have my sum range, and then specify my criteria range, and then my criteria comes last in the same fashion as before there. And so that one's adding up 3 rows. If I change the count number, notice it's 2 different ways to triangulate in on the same data there. We can go further with the operators if we choose by specifying 2 sets of operators. So we can say SUMIFS, where we look at E1 through E5, where it's greater than or equal to whatever's in A3, and then look at E5 again, less than or equal to the second account number. That lets us add up both sets of values there. So to see that, with the SUMIFS function, if I only had one argument, then I can only look at one value. But if I want to look up a range of account numbers here, I could say equals SUMIFS, specifying my sum range first, My criteria range in this case, E1 through E5, greater than equal to that account number. And then my second criteria, think of that as an AND. So AND, looking at E1 through E5, where it has to be less than or equal to cell B3. And so when both of those criteria are met, then it adds up those values there. So the greater than equal to is known as operators, and that is how we incorporate those into our SUMIF function, or also SUMIF, to be able to add up ranges of numbers. Now, SUMIF and SUMIFs give us a lot of flexibility, but there's one area where they can be a little frustrating if our formulas are reaching into other documents. I don't mean by reaching into other worksheets, but actually connecting to other files, so that we're creating a workbook link. SUMIF and SUMIFs can only return results when the other workbook is actually open. And so if that presents a problem for you, there is another way to look up results from other workbooks by way of the SUMProduct function. So what the SUMProduct function allows us to do is the same thing we did with SUMIFs, but it doesn't matter if the other workbook is open or not. So if you wanted to be able to look up data from a different workbook and not have to worry about if the other file was open or not, we can use the SUMProduct function in this fashion. And I'll show you what that looks like. So we saw the SUMIFs before. We could say SUMIFs. We could say I1 through I5. Our first criteria would be E1 through E5, greater than, equal to that account number, referencing our second criteria, which is, again, E1 through E5, less than, equal to the second cell. So that adds up our results. If I wanted to do that with the SUMProduct function, I could say SUMProduct. And in this case, I'm going to put the cells in parentheses. Now, I can't include row 1 because I can't have any text. So I'm going to say E2 through E5 greater than, equal to A3. Notice there's no ampersands and there's no double quotes there. Put an asterisk, not because we're multiplying. Think of it more as an AND. So I can then say also look at E2 through E5 less than, equal to B3, close parentheses, and then the and when both those criteria are met, add up the values for I2 through I5. So that gives me the same result as SUMIFs, but if I'm looking up data from other workbooks, doesn't matter if the other workbook is open or closed. So normally I would use SUMIF or SUMIFs, but if I need to link to a workbook that could be closed, then SUMProduct is a better alternative there. All right, well, that brings me to the end of my prepared comments for today, so I'm going to turn the floor back over to our moderator to manage the Q&A portion.
Thank you, David, for the wonderful presentation. Now it's time to begin a Q&A session. I'm going to unmute all the lines of attendees. Please request you to ask all your doubts if you are having any. I'm just unmuting the lines. Still, you can send your questions to chat window. Yeah, I have unmuted the lines. Please go ahead and ask the questions. Hello.
Hello, I have a question about the operators.
Okay.
Yeah, you can go ahead.
Is there any operators where you can do a does not equal rather than greater than then? Is there a does not equal?
Sure. So let's say that we have, we're going to put in 100, and then for these cells we'll put in 500. And then I'll just make up some numbers over here. So what you're saying is so the sum of all those, let me make these quit changing here. This is the sum of all those cells there. But let's say hypothetically you want to add up everything except the 500s.
Right.
So two ways we could get at that. One, we could say SUMIF, and we could sum that where it's 100, and then get those values. But if you want more of an exclusionary approach, then you could say SUMIF and look at this. And we would do, this is how we do the not equal to. So we could say not equal to 500, and then we would reference those cells there. And so it's two different ways to get at the same result. So instead of a greater than equal to, you're using putting the two symbols together, that means a not equal to. So if I had the 500 in a worksheet cell, it would look like this. It would say SUMIF, adding that up, and put these together and then connect on the cell value, and then I would add up my result. And so you could, what did I do here? I missed a comma. There we go. So you could use that same convention inside SUMIFs, because it sounds like you might have multiple criteria and you want to, match on certain criteria but have it where it doesn't equal something else. That's the operator that we use.
Okay. I have a question as well. Is there a way to, bring back a result of a color? Like, let's say you have two tabs. One might represent your sales, one might represent your payables, and you want to go through and see everything in the sales that have been paid, and so you would be using a lookup function or a VLOOKUP to find it in the two tabs, but the return that you want is you want to highlight it.
That requires using Visual Basic Programming Code. There's not a built-in formula that will let you do that.
Okay.
You can, and I can send you the code if you want it. You can create a custom worksheet function that you would have to add to each workbook. So there's not a universal approach for doing that.
Okay, no, that's fine. We're just trying to look to automate some of our, the highlighting that you tend to do in finance when you're trying to make sure you're reconciling. And, but I mean, there's other ways to do it. We could return a text that says AP or something like that identifies that it came from AP. Right now, we're just used to colors. Like our colors are telling us how our sales are being cleared off.
Well, and let me show you what I would suggest in that regard. Let's say that you put an X if it were paid, and you want to have colors. Then we can use. So I'm going to select these first two cells here. I'm going to go and choose conditional formatting, and I'm going to say I want a new rule. And so I'm going to say I want to use a formula where, in this case, I'm going to say cell C1. And I need to make sure that there's no dollar signs here. So I can press the F4 key to get it. So I want C1 equal to X. So I put my X inside double quotes. And so if cell C1 is equal to X, I can then go to Format, and then I can pick my color and click OK. So
that's great.
You would only apply it to the first row first. Once you have it set, then we can take and paste the formatting to the other rows. So we went to conditional formatting. We chose a new rule. We're checking to make sure there's no dollar signs, so it's equal to X, picking your color, clicking OK. Then we use the format painter to grab those two cells and then paint down here. And, okay, actually, I know what I did wrong. If I go back to my conditional formatting, I want to put a dollar sign in front of the C, but not in front of the 1. I want to freeze the column, but not the row number. So if I click OK and click OK, now if I came along here, as I mark these with an X, then they will get color-coded.
Oh, that's great. That's awesome. Thanks very much. That's a great
And then with the
tool.
X, then you have something tangible to do your lookup on as well. So you get a 2-for-1 there.
Yeah. Right. Awesome. Okay, very good. Thank you.
Thank you.
Yeah, thank you, David, for answering. Do you have any questions? Anyone having any questions? Please go ahead and ask your questions now. It seems there is no question at the moment. Even I'm not seeing any question in the chat box as well. Hope our presenter answered all your questions. However, you can still send your questions to our email ID, that is support@ijonaskills.us. With this, we will end the session. We appreciate your time and believe the session was informative and up to your expectation. Soon you would be receiving certificate of attendance and the feedback form. Kindly come and give your feedback. Your feedback is important for us. Once again, thank you so much for participating in this webinar, and we wish you a pleasant day ahead. Thank you, David, for the wonderful presentation.
My pleasure.
Okay.